React Native is a powerful cross-platform mobile development framework created by Facebook that allows developers to build native mobile applications using JavaScript and React. Instead of writing separate code bases for iOS and Android, React Native enables you to write once and deploy to both platforms. The framework bridges JavaScript code with native platform components, delivering performance that's close to native applications. React Native has become the go-to choice for companies like Facebook, Instagram, Airbnb, and many others who need to develop mobile apps efficiently. Today, we'll explore the most important React Native interview questions covering components, navigation, native modules, performance optimization, and deployment strategies. React Native provides a set of core components that serve as the building blocks for mobile applications. Unlike web development, where you use HTML elements like div and span, React Native uses native components that compile directly to platform-specific equivalents. The View component acts as a container similar to a div in web development, supporting Flexbox layout for responsive designs. Text components handle all text display and styling. Image components manage various image formats and can load from local sources or remote URLs. TextInput components handle user input with built-in validation and formatting capabilities. These components automatically render as native iOS and Android elements, ensuring your app feels natural on each platform while maintaining a single JavaScript codebase. JSX, or JavaScript XML, is a syntax extension that allows you to write HTML-like code within JavaScript. In React Native, JSX enables developers to create mobile interfaces using a familiar structure while leveraging the full power of JavaScript. Unlike Web React, where you might use div and span elements, React Native JSX uses mobile-specific components like view and text. You can embed JavaScript expressions directly within JSX using curly braces, making it easy to display dynamic content, handle user interactions, and manage component state. JSX gets compiled at build time into native components, ensuring optimal performance. The syntax supports inline styles, conditional rendering, and component composition, making it an intuitive way to build complex mobile interfaces while maintaining code readability and organization. Creating custom components in React Native follows the same patterns as React for web development. Functional components are the modern standard, utilizing hooks for state management and side effects. When building a component, you start by importing necessary React Native components like view and text from the React Native package. Components receive data through props, allowing for reusable and configurable UI elements. Stylesheet integration keeps your styling organized and performant by creating style objects outside of the render method. Component lifecycle management is handled through useEffect hooks, enabling you to manage mounting, updating, and unmounting behaviors. Well-designed components should be modular, testable, and follow single responsibility principles to ensure maintainable and scalable mobile applications. Navigation is a crucial aspect of mobile app development that enables users to move between different screens and sections of your application. React Native supports several navigation patterns to match different user interface designs. Stack navigation creates a hierarchical flow where screens are pushed and popped like a stack of cards, perfect for drill-down experiences. Tab navigation provides quick access to main sections through bottom or top tabs, commonly used in social media and productivity apps. Drawer navigation offers a slide-out menu from the side, ideal for apps with many features or settings. Each navigation type has its own use cases and user experience benefits. The React Navigation Library is the most popular solution, providing comprehensive navigation capabilities with smooth animations and platform-specific behaviors for both iOS and Android applications. React Navigation is the most widely adopted navigation solution for React Native applications, offering powerful features for managing screen transitions and user flow. Implementation begins with installing the navigation library and wrapping your app in a navigation container component. Screen parameters allow you to pass data between screens, enabling dynamic content based on user selections or previous interactions. Header customization options provide control over navigation bars, including titles, buttons, and styling to match your app's design. Nested navigation structures enable complex app architectures by combining different navigation types, such as tab navigation within stack navigation. The library supports platform-specific optimizations, ensuring navigation feels native on both iOS and Android. Performance is optimized through lazy loading and efficient screen management, keeping memory usage low even in apps with many screens. Native modules provide a bridge between JavaScript and platform-specific native code, enabling React Native apps to access device features and APIs that aren't available through standard components. When React Native's built-in capabilities aren't sufficient, native modules allow you to write custom functionality in Java for Android or Objective-C and Swift for iOS. This bridge architecture enables access to platform-specific APIs like camera, GPS, sensors, or third-party SDKs. Native modules are essential for CPU-intensive operations that need better performance than JavaScript can provide. The communication between JavaScript and native code happens asynchronously through a serialized message system, ensuring the main UI thread remains responsive. Understanding native modules is crucial for building feature-rich applications that fully utilize mobile device capabilities while maintaining the development efficiency of React Native. Building custom native modules requires understanding the bridge architecture and following platform-specific implementation patterns. The process starts with creating a native module class that extends React Native's base module classes. On Android, you'll extend React context-based Java module and use the React method annotation to expose methods to JavaScript. The module must be registered with React Native's module registry to make it accessible from JavaScript code. Methods can return promises for asynchronous operations, allowing JavaScript code to handle success and error cases appropriately. iOS implementation follows similar patterns using Objective-C or Swift with RCT Bridge Module Protocol. Testing integration thoroughly is crucial since native modules involve platform-specific code that can behave differently across devices. Proper error handling and documentation are essential for maintainable native modules that other developers can understand and use effectively. Performance optimization in React Native focuses on achieving smooth 60 frames per second rendering and responsive user interactions. React Memo prevents unnecessary component re-renders by comparing props and only updating when changes are detected. Flat list and virtualized list components efficiently handle large datasets by rendering only visible items, dramatically reducing memory usage and improving scroll performance. Image optimization involves using appropriate formats, sizes, and caching strategies to minimize bundle size and loading times. Native animations using the useNative driver property ensure smooth animations by running on the native thread instead of the JavaScript thread. Memory management requires careful attention to component lifecycle, avoiding memory leaks through proper cleanup of timers, subscriptions, and event listeners. Hermes JavaScript engine provides additional performance benefits through ahead-of-time compilation and reduced memory usage, particularly beneficial for Android applications. Navigation performance significantly impacts user experience, requiring specific optimization strategies for smooth screen transitions. Screen preloading involves initializing upcoming screens before navigation occurs, reducing perceived loading times and improving responsiveness. Memory management becomes critical with multiple screens, requiring proper cleanup of unused screens and components to prevent memory leaks. Native animations with useNative driver set to true ensure smooth transitions by running animations on the native thread rather than JavaScript. Screen configuration optimization includes minimizing header complexity and using appropriate animation types for different navigation patterns. The React Native Screens library provides additional performance benefits by using native screen management instead of JavaScript-based alternatives. Regular profiling helps identify navigation bottlenecks and memory issues before they impact users. Proper navigation architecture prevents common performance pitfalls while maintaining smooth user experiences across different device types and operating systems. Effective memory management prevents crashes, improves performance, and ensures smooth user experiences in React Native applications. Memory leaks commonly occur through unclean timers and intervals that continue running after components unmount, requiring proper cleanup in useEffect return functions. Event listeners and subscriptions must be removed when components unmount to prevent memory accumulation over time. Circular references between objects can prevent garbage collection, requiring careful attention to object relationships and reference handling. Image caching needs limits to prevent excessive memory usage, especially in apps that display many images or large media files. Component lifecycle management through proper useEffect usage ensures resources are allocated and deallocated appropriately. Regular memory profiling using development tools helps identify leaks and optimization opportunities before they impact production users. Understanding JavaScript garbage collection behavior helps developers write more memory-efficient code that maintains performance across extended app usage sessions. Successful React Native deployment requires strategic planning across multiple distribution channels and release approaches. The Apple App Store serves iOS users with strict review processes and guidelines that must be followed for approval. Google Play Store provides Android distribution with more flexible policies, but still requires compliance with platform standards. Enterprise distribution systems enable internal app deployment for business users without public store involvement. Over-the-air updates through services like CodePush allow immediate bug fixes and feature releases without App Store approval delays. Staged rollout strategies gradually expose new versions to increasing user percentages, enabling early issue detection and resolution. A/B testing capabilities allow feature validation with real users before full deployment. Rollback plans ensure quick recovery from problematic releases, maintaining user satisfaction and app stability. Target metrics include 99.9% uptime and crash rates below 1% to ensure production quality and positive user experiences across all deployment channels.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.